Okay, we'll continue here at the innovation stage with innovation, because that's what we're here for. Today, and I think this is quite impressive, we had a day where we talked about different factors that aren't often in the focus otherwise, but they're essential in our industry. And we're going to look at a subject like this right now, because now we're going to look at what the significance of coolants in production is. So welcome with me, Julian Moorman, Managing Director of EM Solutions GmbH. I'll be talking about smart machines, dumb coolants. Coolant as an underestimated lever in manufacturing. Over to you. Thank you. Thank you for those words of introduction. That's the subject. Smart machines, dumb coolants, coolant as an underestimated lever in manufacturing. What's this title all about? That's the key question here. When everything's automated in production, you see that everywhere. Why not coolants too? How are we going to tackle this? What's the agenda here for my presentation? Well, we'll first of all say what the status quo of automation is today, automation in general, and then in particular machine tools, and then coolants. What are the problems I've got if I don't automate? What do we think of automation? How can we rethink this for coolants? Doing it holistically, and then what about specific implementation? How will this really work with the solution we offer? And then we'll have a look at it in actual practice, in application. And after that, I'll have a little time for questions and comments that we can talk about here on stage or afterward or at our booth. Now, before we move on to the specific subject, I'll start with some general things. That is, this is a subject from the past few years that's very important in society here at the trade show. AI, ChatGPT, automation, the big subjects of our day and age, things that we're all dealing with now. And all of us here, too, are dealing with this. I was recently at a meeting. I went to see a customer, and there were different colleagues there on site from different divisions, application engineers, from planning, from different divisions and departments, and we talked about ChatGPT. And there was actually no one there who didn't use ChatGPT and was even using it on a daily basis in their business activity. So there's no way around it now. The basis of everything, of AI, of all of these different things, is data. And we just heard a wonderful presentation where we heard about that. Data, linked data, that's the foundation, the basis of everything I can do with automation, AI, and everything else. And the importance of data is just impressive. Recently, we saw news about how Facebook bought a startup for 15 billion euros, 49% of scale AI. I don't know whether anyone has heard about them. It's a company that does only one thing: labeling, linking, describing data. And after just a few months and years, that's worth more than 30 billion euros, that company. And you see a 100-year-old German machine tool manufacturer being sold for 100 million. But this is the reality we've got to deal with, and this shows, and this is why I'm saying it, that shows how important the subject of the basis of data is. We, of course, now want to automate everything. You've got ChatGPT, but I've got the unitary robot here. We saw that at the trade show in Berlin recently. Maybe some of you did. And in the future, apparently it's going to become part of our everyday activities, and it'll do general everyday processes automatically. And it's going to be astonishingly low in price. Apparently it's already available now. And all of these automation things are reaching our everyday lives now. And now let me make a jump to machine tools at the trade show. That's what we've been talking about here for years and decades. Automation, this is something that we've always been talking about at trade shows like this. And we, of course, want to move forward with automation here. These are the machines. They're smart. We look here. We look Hall 14. We look at Hall 2. State-of-the-art machine tools are smart. They incorporate data. They do all of these different, take all these different subjects into account. Coolants, that's often not too smart. It's actually pretty dumb. That's why I have this title of my presentation. There's still lots of potential there. Cooling lubricants, supply management, doing all of this intelligently. Now, why is it a bad idea not to do it? Why is it a bad idea to manually do coolant management? Well, there are different reasons for that. First of all, documentation. If you work with cooling lubricants, you've got to document lots of things. We in Germany are pace setters here. We work together, TRG 611. A lot of people know that there are prescriptions in there. Every week for 10 years, you've got to document coolant values. So there's a lot of work to do there, and we've got a big problem because if you do it manually, it's just a lot of work and therefore expensive. Next subject, employee protection, employee health. Coolants, of course, when people come into contact with them, they can be a health risk, and that's why you shouldn't directly contact it. So people working with the coolants, they are subject to a certain risk. And then environmental protection, because coolants, of course, well, they're an oil-based substance, so environmental protection plays a major role here. Therefore, it's important in production and also when you get rid of it, it has an impact on the CO2 footprint of a company. And then with manual coolant management, well, you have to really focus on this a lot because you'll use more coolant and you have a lack of efficiency. That all sounds fine and well, nice to have, important subject, okay, but what's especially crucial is this, the process costs in production. Let's have a look at these. This is analysis done by Daimler. AG, overhead costs, general costs, most important. The buildings, that's a big point in production. Then there's 8% setup cost, that's a big share. Then, of course, you've got machine costs, right down. But then you got 4% tool cost. But another major share is coolant cost, 16%. And that's very important, so it offers lots of potential. Compared to manual management, you could have automated management. Now let's go on to coolant management. What does this involve? What are the different points? Well, you've got measurement here in Germany, but everywhere too. You've got to measure coolant. In other words, concentration, temperature, pH value. These are the key things you've got to look at. You've got to have records on that. And then refilling. Obviously, you've got to have enough coolant in your machine, otherwise it'll come to a stop. You can't produce. You've got a huge problem. That must not happen. And then you've got the next subject, documentation. That's clear in Germany, but not just here. Wherever you have a customer, and if they have high demands for their parts, and they have to have proof and documentation in aerospace, defense, medical, semiconductors, and so on, the demands are very high, and customers demand this documentation. So you've got to supply it. And also, looking back at the subject of AI we talked about, in the previous presentation we heard that 7 years data was collected for training an AI to optimize a later cutting process. Now, this data has to be collected and interlinked, and this is a very important point, and this can only be done with regard to coolant if you think holistically and automate holistically, and you have these three subjects, measurement, refilling, and documentation. You've got to bring all of this together and link them in one system. It's logical. It all has an interplay. If you measure, you can refill more precisely in your machine because you have to measure first to know what the fill level is, what your concentration is, how you've got to react, and the documentation, that's a byproduct. That's there anyway. So in other words, a holistic solution, if you don't do all of these different three things separately and link them together, there are huge advantages. Now, what might a solution look like? Well, I'd like to tell you about our LiquidMate Sense product. This is at our booth F15 in Hall 15. And this subject, coolant management, is looked at here holistically, not just in small blocks. It looks at automation as a whole. So what do you have in this system here? Well, you've got a fill level monitoring in your machine. That's very important, and it understands always what the fill level is in your machine. You circulate your coolant. That's another important point of the system. You have basically have movement there in the coolant all the time. You're familiar with this. In Monday morning, you come into the factory and you smell, okay, well, the coolant was just at a standstill for the weekend. Maybe it was a standstill for a week during vacation. It smells funny. It shouldn't be like that. And this is exactly what can happen if coolant comes to a standstill in the machines and the tubes. And you prevent that because with our system, you have constant circulation overnight and on weekends when the machines aren't even running. Then, of course, another clear thing, measurement, concentration, working temperature. These are relevant values you are interested in as a user. You've got to keep an eye on them for your production. Then refilling. In other words, how you automate refilling so that you don't have to do it manually, and not just somehow with a certain concentration. It has to be done permanently, constantly, so you always have the right concentration. So let's say in production you want to work with a concentration of 8%. You want to always be at 8%. If you do it if you do it manually, you'll be there maybe plus or minus 5, 6, 7% easily. And if you do it automatically, you can always stick to plus or minus 0.3, 0.5%. So that's a completely different situation where you have the right thing for that process. And then, last but not least, you see that at the end here, and it's a byproduct basically of all the rest of automation because you need the data. That's the documentation that we can offer too. Now, I said we offer a holistic solution to cover the whole process, and of course we want to have a user-friendly system. Where is the user? Where is the machine operator? Well, he's standing in front of the machine. So the data has to be where the user is. It has to be on the machine panel, and that's what we make possible. For instance, as a qualified partner from DMG Mori, we were presented there, and we integrated there with their machines, but other machines too, where the machines have data visualized there where it counts, where the worker is, and where the worker then can react. Now, when I began, I promised that we would have a look at this in actual practice. What could it look like in practice? Now, it maybe sounds interesting and nice and exciting, but how can you implement it in actual practice? And here I have an example from actual practice. And there's a report on this for a company called Liebherr. Our system is used there. And one of the users said this verbatim. He said, okay, liquid mate saves a lot of time, avoids sources of error when mixing, reduces the risk of contamination, and significantly reduces consumption. These are the benefits for the user. They calculated things exactly. They looked at it closely. 30% savings in terms of lubricant consumption. There's potential for saving even more. We have customers where the figure there is even above 30%. In this company, Liebherr, they have another very positive point they mentioned. They had certain problems in terms of coolant temperature, high fluctuation because of the heavy processing with the machines. And you had temperature variation across the day. And at a certain point in time, because of evaporation, lots of water had to be added to the machines. That was cold water, and that mixed with the heated lubricant. And so, as you can imagine, there was certain fluctuation in the medium. Then you have a question of tolerance in the machines, the tools, the downtimes, and so on. And if you have this automated over the long term and you have automatic refilling of small amounts of lubricant, you can solve that problem. With temperature, you have much more constancy in your temperature. Is a huge benefit there. These 2 points together, apart from the general advantages of automation, in other words, you don't have to do manual management, you don't have to do handling with refilling, and you save time, so you have the operator doing what he's supposed to do, where he's supposed to be in front of the machine making parts, and the payback period is less than 2 years. It's astonishingly quick, and this is usable in actual practice, in application. Okay, that was it. That was my presentation. Short and sweet. That's what I wanted to tell you about this subject. And last but not least, there was a question that someone asked, that I asked at the beginning. So if the machines are smarter, yes, coolant should become smarter too. Now I'm ready for any questions you might have. First of all, let's give him a big hand. Thank you. That was great. First of all, thank you for the timing. We'll have a look and see whether there's any questions. I'd be interested in something, if I may ask. Today, we talked about lubricants and coolants. These are areas that are often neglected, but this is everyday business, right? Yes. And as we've heard, developments are so fast. Now, what about the perception of machine makers? Are they aware of how important this subject is? Or do you have to say again and again, hey, people, it's not just a simple coolant? Well, in my opinion, it's a bit of a trend. Machine manufacturers really are focusing on this now. They say, okay, peripherals, everything around the machine tool, process optimization, that's becoming increasingly important. That's why cooperation with industry partners and institutions is so important. And we're hearing this, because there's so much potential in there to increase efficiency. For instance, with cooling, lubricant management, by handling of chips and oil and so on and so forth. So there are a lot of things which are really important for final customers. They're great business cases for them because you enhance efficiency and you have a really quick payback period, and that's important in the current day and age where budgets are tight. And you also see that machine manufacturers are understanding everything in the peripherals. So you are asked a lot about payback period when you have a new solution? Definitely, that's logical. That's obvious. In recent years, that's become increasingly important because it's extremely difficult nowadays for some companies, and you need systems that help you save money. Because a system like this, automation like this, users want that because then they have less work to do. They're a fan of this type of system, this type of technology or investment, this type of innovation. However, the decision makers who have to make that investment, they want to do that too. But of course, there are limits for them. Limits of what they can do, where they have to focus. And payback period is really like the core subject. How much potential is still in there? That would be interesting to know. Now, you have a young guy saying, okay, maybe 1-2 years, and that'll be the end of the line. No, how much is in there? Well, definitely, there's a lot of potential. We think there's a huge amount of potential. I personally think that too. Otherwise, for young people, there are other industries where there's a boom, where things are going on. But in Germany, in mechanical engineering and for production, well, these are areas where we can move forward, become competitive, stay competitive, and make headway. Thank you very much. That was it. Thank you very, very much. Let's give him a big hand, ladies and gentlemen. Great presentation. Wonderful subject. Thank you.